Okay, so let us start our today's session. So, first of all, I would like to welcome you all for joining us for a webinar with Business Toys. So, today we'll be discussing about one of the very important and a specific topic about one particular aspect of data science. So that is about like machine learning specifically. Now, in order to go ahead and do further things and or understand further things, first let me introduce myself. So my name is Manikanta Prasad. So I'm a vice president for University Connect and Corporate Connect. So also I work specifically into machine learning related projects. So I take care of a lot of data science projects specifically into machine learning because my core expertise is into machine learning specifically. So once again, I would like to welcome you all for this webinar. So today's webinar will be about supervised versus unsupervised machine learning. Now, what is this unsupervised or supervised machine learning? So those people who are new to it, okay, first of all, can you guys tell me how many of you who are here, okay, how many of you who are here who is, like completely new for this particular aspect of machine learning? Can you just comment it as yes, if at all, if you are new, or if you can also raise your hand if at all, if you are new for this, anybody? So I just want to know how many of you are new for this. Okay, I see a couple of hands there. Okay, pretty good. Now, today, so, since this machine learning is new for you, but since if at all, if you're looking forward for this kind of a webinar, probably you would have either shown your interest towards, data science, or at least something relating to data science you would be aware of. So, today, let us understand what is this machine learning. And when it comes to our specific topic, that is supervised versus unsupervised machine learning. So, we'll see what basically it is and how it is basically. Now, coming to machine learning. Now, can anybody, okay, so can anybody just give me a brief, okay, based on your understanding, what is machine learning according to you? Can anybody give me an overview? You can just, put a comment there. Okay, so you can just put a comment there so that I would read your comment if at all if you have an answer. So you can just put a comment there. What is machine learning according to you? Like probably you would have come across this particular term called machine learning. So any idea, anybody? What do you mean by machine learning? Like have you come across these term called machine learning specifically? What is it basically? Okay. So if at all, if it is like you're not aware of this, now one thing which you should understand is machine learning is one of the very important topic, like one of the major topic in the field of data science, where we work with a lot of predictive analytics, a lot of predictive models. We use a lot of machine learning related algorithms for predicting or forecasting the future outcome based on the present data or the past data which is available. So for doing all that processes, we use something known as machine learning. But what exactly does a machine learning do? So let us understand this. So basically, so machine learning, it gives a system an ability to learn on its own and automatically to improve based on its learning experience without explicitly being programmed. Now, what is this basically? Probably for the people who are looking at this for the first time, you this could have been looking like somewhat new for you. Now, what exactly machine learning does? It gives some sort of a power or some sort of a ability to a particular system so that that particular system can start learning things upon a particular data on its own. Now, when we say a system is learning things on its own, what all things a system could learn about? When you have a data, it will start understanding the information which is there in the data. It will try to understand the pattern which is there in the data. Okay, what sort of information is given, what sort of different, variables which are available, or what sort of, pattern or a structure can be, observed in a data. All that it automatically starts observing. So once when it is observing certain things like structure or be it patterns in the data, that is where it will start understanding those structures in the data or patterns in the data. So once it starts learning, so every time it looks at a pattern or every time it looks at a structure, it will understand it. So every time it look once again it tries to learn it or see at a structure more and more, it gets more and more experienced towards understanding that structure. So for doing this, the major advantage of machine learning is you don't have to be a hardcore programmer. So that is what basically it says. Like basically, so it will automatically improve the ability of learning, okay, with its experience without explicitly being programmed. This is one of the highly, like advantage which is there in our machine learning. So gone are those days where if at all if we have to build a predictive model, we had to sit and write huge amount of codes, huge amount of program, where it used to consist of all the logics, all the math calculation, everything. Whereas now your machine learning has made the things so simple and so like in a structured manner, so that even anybody, okay, you come from a coding background, you come from a non-coding background, you can easily learn it and you can work on it specifically. So that is one of the highly advantageous procedure which machine learning is giving us. So probably you would have got a brief idea now. So basically it is just like a ability which is provided to a system in order to understand or learn on its own, okay, and automatically improve that learning based on its learning experience without explicitly being programmed. So this is what basically is machine learning. Now, coming to machine learning, so the next thing is, let us move on to what are the in-depth things which, if at all, if you're focusing on learning machine learning, what all things you should actually focus on, what all things comes here. So let us understand everything one by one. Now, under machine learning, so anybody has any idea, like, is there any sort of types in machine learning? Have you come across any sort of any types in machine learning? If at all, if yes, can someone tell me what sort of types which you have come across? Anybody? Is there any types of machine learning which anybody has come across? If at all, if you are aware, if you can share it. Anybody? Okay. So I have an answer like supervised machine learning. Okay, very good. I have another answer like unsupervised machine learning. Very good. There is something like, okay, reinforcement machine learning. Pretty good. Now, so when it comes to machine learning, okay, so we use certain types of machine learning specifically in order to, work on a lot of prediction or, predictive modeling and things like that. Now, among them, so let us go one by one and understand everything. The first one is something like supervised machine learning. Okay, so this is the first part or first type of a machine learning, which, if at all, if you are looking forward to learn machine learning, you should be knowing. Now, what is this supervised machine learning basically? So basically, supervised machine learning is a technique which is used in order to build a lot of predictive models with the help of your machine learning algorithms like linear regression or logistic regression. Okay, so like there are still multiple algorithms which I don't want to specifically go in depth because most of you are completely new for this. But at least most of you would be aware of what is a linear regression or what is a logistic regression. Now, all those regression techniques, okay, we call it as a machine learning algorithms because these things comes under supervised machine learning. Now, what is the speciality of a supervised machine learning? Let us understand that. So basically, your supervised machine learning is used upon a particular data which is labeled. Okay, so this is very important here. So whenever your data is completely structured with proper labeling in it, okay, whenever you have a data which is consisting of a proper labels on it. Okay, so what such data can be used for building supervised machine learning models. So what basically here is, if you see here, I have two data. Now I have a data called like in one particular information in the data is apples. I have another one as cupcakes. Now I have the data which is clearly labeled. So once the label data is labeled, what my machine learning model will do is it will try to understand the data based on these labels which have been mentioned there. So based on the labels which is mentioned, it will try to learn or and build the model. So once it builds the model, and whenever I give some new data, okay, whenever I give some new data which is unseen by this model, it will try to do the prediction, or it will try to do the forecasting for it. So this is one of the major ability of your supervised machine learning. So supervised machine learning is something which is always used for a labeled data. Okay, when you say labeled data, you will be having all the variables or all the columns which are properly listed along with their names, so that as soon as you look at the data, you will be able to understand what information have been given. Such data is called as a labeled data. So for those labeled data, if at all if you have to perform a predictive analytics or predictive modeling, then you will always use supervised machine learning. Now, some of the supervised machine learning algorithms, which I already said you, is like one is like your linear regression, another one is like logistic regression. Apart from this, there are still multiple, which are there. There is something like decision tree. There is something like random forest. Now, all of these things comes under supervised machine learning. Okay, that is, like which specifically consists or takes labeled data for doing the predictions. So anybody has any questions so far here? Okay, so anybody has any questions so far here upon your supervised machine learning? Is this supervised machine learning clear what exactly it do? If you have any questions, you can ask me. So anybody, any questions? So is this supervised machine learning, what specifically it do, or when do we use this supervised machine learning? Is it clear for all of you? So if you're clear, you can just comment it as yes, or if at all, if you have any question, you can just comment with your question so that I would like to answer your questions. Okay, it seems to be there is no questions or nothing. So I believe that it has been understood for all of you who are present here. So now let us go to the next type. Now this is the first type of machine learning. So the second type is something like unsupervised machine learning. Now, what is this unsupervised machine learning? Basically, being the second type of machine learning. Now, unsupervised machine learning is a technique which is used for a data which is unlabeled, just an opposite to your supervised machine learning. So, your supervised machine learning uses a labeled data, whereas your unsupervised machine learning uses an unlabeled data. Now, what sort of a data could be an unlabeled data? Let us understand with this example of an image which I have here. Now, if you can see, I have multiple, like vegetables and fruits which are mixed up here. Now, this is my input. So I am not giving any specific information for my model saying like, do I have a tomato? Do I have an apple? Do I have a mango? No information is given to my model. So, which is completely jumbled like this without any proper information which is provided here. So, whenever the data is completely messed up or mixed up without any proper labeling which is available there, such data is called as unlabeled data. So, whenever I have such unlabeled data, when I give it to my model, what does my unsupervised machine learning model do? Understanding this is very, very important. Your like unsupervised machine learning specifically tries to understand the patterns and the structure in the data which you are giving it. So it will try to observe each and every single information which is there. So like for example, if at all if it is observing a tomato, it will observe the color of it, it will observe the shape of it, it will observe the size of it. Similarly, if it is what observing a mango, again it will observe the shape of a mango, it will observe the color, and it will observe the size of it. So like that, what your unsupervised machine learning does, it basically observes the structure and the pattern which are hidden. Now, these pattern we cannot understand as a human being because the data is not labeled. If at all, if the data is labeled, you can clearly understand what information is clearly given there. Now, since you as a human, if you are not able to understand what information is given, such data will be given to unsupervised machine learning. So the job of unsupervised machine learning is to look into that data and to extract the hidden features, or in order to extract the hidden structures which you cannot notice. So your unsupervised machine learning will try to extract such hidden information or hidden pattern from the data, and based on that it will give you a proper analysis as to what sort of a structure you have in the data, or what sort of hidden information you have in the data that can be obtained with the help of your unsupervised machine learning. So this is one of the major difference between your supervised and unsupervised. Supervised is used for a labeled data where every information is clear, so that automatically once all the information is readily available, your supervised machine algorithm will take it and it will try to do the further analysis. Whereas unsupervised machine learning, it is always used for a unlabeled data where there will be no labels for your data. Without labels, it will be very difficult for you to understand what structure the data is with, or what sort of patterns does the data has. So when you come across this kind of a situation, that is where your unsupervised machine learning will try to understand the pattern on its own. Okay, it will try to identify the hidden structure or the hidden pattern which is there on its own. So once it understands, so how does it understand? It will try to observe each and every single data. So what sort of a, is there any sort of a pattern which is available, or if at all, if you give certain images like this, it will observe the shape of it, or it will observe the color of it. So like this, it will observe each and every single thing which is available. Based on that, it will try to give you the pattern which it can find it. So this is one of the major difference between your supervised and unsupervised machine learning. So is this difference between supervised and unsupervised machine learning is clear for all of you? Anybody has any question? If you have, please ask me. So we have Soundarya with us. Soundarya, you have any questions? Kausalya, do you have any questions? If you have any, please ask me. Is the difference between supervised and unsupervised clear for you people? John, any questions from you? We have Karthik. So Karthik, any questions from you? Okay, Mohan, do you have any questions? And all others, since there's too many people, I cannot take everybody's name, and I cannot ask if at all if you have a question here. So please I hope you bear that. So overall, I would like to ask, if at all if you have any questions anywhere, you can ask me. So I believe like the difference between your like supervised and unsupervised machine learning is clear for all of you. Then now let us go to the next one. Now, apart from your supervised and unsupervised machine learning, there is one more type of machine learning called reinforcement learning. Now, this is something which is pretty new, and this is something which is little bit more complex compared to your supervised or unsupervised machine learning. So what is this basically? What happens here? Let us understand. Now here, under reinforcement learning or reinforcement machine learning, basically it works something like this, where it will have a system, or it will have a agent, okay, who will be representing as a reinforcement learning a system or an agent specifically. So the job of this agent is to do certain actions upon some environment which is completely unknown. Okay, so the main job of this agent is to do certain actions. What sort of actions? It could be in terms of extracting the data, understanding the environment which that particular agent is around. So it will try to get into that new environment which this agent has never seen. So it will try to get in there, and it will try to collect the data on its own. Once it collects the data, then it will observe it, and it will try to learn and understand based on the observations which it makes. If at all if the observations is good, then it will have a good positive results. If at all if the observation which is made by this particular agent, if it is bad, then it will have to face the sequence. So here it is unlike your supervised or unsupervised machine learning, where the data is available. So once you have the data, if you're going with supervised machine learning, it is like completely available with the labels and everything. So easily it can analyze the data. Whereas coming to your unsupervised machine learning, so you will have the data but without labels. So it will have to find the hidden structure. Whereas the problem with reinforcement learning is neither you have a data or any information. So in order to do certain analysis, first thing is like the agent has to find the data or collect the data on its own. So once it is collecting the data on its own, that is when it should automatically get into the next step of analyzing it, or performing like identifying the patterns in it or structure in it. Based on that, it should follow its own analysis. So it is like everything, it is up to the agent how it is doing. Now the best example for this I'll give you. Now probably anybody recognize this image? Can anybody recognize this image? What is this image? Anybody can, have you seen this image by any chance? Anybody? Has anybody observed this kind of an image or something like this before? Yes, no, anybody? Celia, Soundarya, have you guys observed it by any chance? Have you seen this kind of a image by any chance anywhere? Okay, so probably maybe you would have not seen it. Okay, now this is nothing but a rover, okay, which was sent to Mars by NASA. Now, this particular rover, what is the job of this rover? Basically, it has to, once it gets landed, okay, like already it has got landed onto the Mars. Now, the job of this rover is to, it doesn't know where it is. Okay, it doesn't know what sort of environment it is living with. So, what this rover has to do specifically is it has to collect the data or the information on its own. So what sort of information it will calculate, collect? First thing is like it will, collect the information of how is the temperature in Mars. Okay, once it collects the information, it will try to observe it and analyze whether that particular temperature is, suitable for human beings or not. What is the air pressure, or how is the soil, or how is the mud which is there. So now for this particular rover, there is no information or no data which is available. Everything it has to do on its own. So if at all, if the analysis is good, that will give that good rewards, or if at all, if the analysis is bad, then it has to face the consequences automatically. So this is how basically your reinforcement learning works, where you will have an agent. This agent will be altogether on itself. Okay, there will be no data, nothing. So this agent is responsible for collecting the data. Once the data is collected, it has to like analyze it. Once it is analyzing it, it has to go through the complete observation, and then it has to make its own interpretation on its own. Everything is on the particular agent itself. So this is what is called as the third type of machine learning, that is your reinforcement machine learning. So is it clear now, all of you? Everybody? So this is nothing but your reinforcement machine learning, where everything has to be taken care on its own. Okay. Now, these are the three major things which are there. Now, let us see some of the examples of, or let us see a little bit more in depth of what happens specifically, what sort of things we can actually do with supervised machine learning, or what sort of things we can do with unsupervised machine learning or reinforced machine learning. So first thing, when we go to supervised machine learning, your supervised machine learning is again subdivided into two. One is something like classification, another one is something like regression. Now, your supervised machine learning is sub-classified into classification and regression. What is this classification and regression basically? We know that supervised learning uses a labeled data. When we have a labeled data, okay, we will have usually data which will be having a target column. Target is nothing but a dependent variable in the data, which we would like to do a forecast or to do a prediction on. So whenever you have such target data, if at all, if that target data is in the form of a binary classification. Now, what is a binary classification? For your information, binary classification is where it will be in some, it will be in a kind of yes or no kind of a thing. Like whether, if at all, if you have to predict whether there is a cancer in this particular patient, yes or no, or whether this particular, customer is going to buy my product, yes or no. Okay, so whenever you have such classification, or when your target variable is categorical in nature, in that case, for doing the prediction, we call it as classification based, supervised machine learning. And when it comes to regression, so basically your target variable will always be a continuous value, that is numerical value. So what sort of numerical value you may have in your target variable? One could be in terms of, let us say, revenue, or let's say in terms of sales, or in terms of, let us say, the performance, so which is measured in the numerical form. So anything which is performed, like measured in the numerical form, when it is considered as your target variable, so in that case, when you're doing any sort of a prediction, we use regression based machine learning, like supervised machine learning algorithms. So what sort of problem statements usually we try to solve? When it comes to problem statement of classification based supervised machine learning, we try to use this classification based supervised machine learning for detect, like fraud detection. So usually this happens in a lot of insurance companies and banks, where they try to detect, if at all, if a particular customer happens to be a fraud, or if at all, if he happens to become a genuine customer. Similarly, when it comes to your hospitals or healthcares, specifically to diagnostics, so they may like predict, saying whether this particular person has a particular disease like this or not. Or coming to your retail sector, or like where, like be it in terms of online retail, or any such retail kind of a structure, where you can talk about customer retention. Many of the banks do this, so they try to predict whether the customer will be taking our service further, or will they be switching into some other particular service. And a lot of telecom companies, who are providing internet service and all that, they usually try to work on this, where they have to predict whether the customer is likely to continue our internet service, or whether they are likely to take some other customers, like some other internet service. So that is where we use that as attrition, basically. That is so basically we try to just check whether if the customer is leaving our particular service or not. Now, along with this, the next thing is like image classification. This is one of the major thing which is being built in the data science industry, where if you have couple of images like of dogs and cats, right? Your model can predict whether, whenever you give a new image, it will automatically predict whether that image is of a dog, or whether if that image is of a cat. So all that can be done using your classification based supervised machine learning models. Coming to regression, we can do a market forecasting or price prediction. What could be the probable price of a particular product, or something like that. We can do advertising popularity prediction. If at all, if we are trying to run a campaign, what will be the popularity of that specifically, can be understood there, to what extent it will go up. And also revenue forecasting. So these are some of the like a kind of a specific cases where specifically we use classification based supervised learning and regression based supervised learning. Whereas coming to your unsupervised machine learning, basically, so there is something like dimensionality reduction. Okay, this is one of the very, very important technique which is used for working on multiple things, like feature elicitation. So elicitation is something where you try to do a lot of feature elimination technique whenever you are dealing with too much of features in the data. Okay, when where you are building a model with too many features, that will result in model complexity. It will result in making the model complex to understand the data and build the model. So in order to reduce that, or for like data visualization, or like reducing the dimensionality, like converting a 3D diagram into 2D diagram, to watch it, or to observe it, or to 1D diagram, or reducing that dimensionality specifically in order to do that, and also to get with lot of meaningful compression. So in order to get a lot of meaningful information by reducing those dimensions, and also to understand the structure of a particular data, we use this dimensionality reduction technique specifically, which comes under your unsupervised machine learning. So when I say structure discovery, if you can remember when I said about unsupervised machine learning, basically it will try to identify a hidden structure on its own, if at all, if we are not able to identify it. So that is the major thing which it does specifically. And apart from this, there is the next one, that is something known as clustering. Even this is one of the highly important method, or a particular process which we use under unsupervised machine learning. So it is used for a lot of customer segmentation, recommendation, and for targeting a specific group of customers, or group of target market specifically. For doing all this, we use clustering specifically. Now, apart from this, when it comes to your reinforcement learning is also used for specific purposes in industry, like skill acquisition, for robotics, for artificial intelligence, and also for real-time decision making. So it is specifically like it will have someone called as an agent. Now this agent will specifically try to collect the data. Once the data is collected, it will try to analyze it, observe it, and based on that, it will try to interpret on its own. For doing all of this specifically, this is used, like your machine learning is used. So when you talk about machine learning, it is about supervised, unsupervised, and reinforced machine learning. So these are the specific things you should be knowing, if at all, if and you should be learning it practically, if at all, if you would like to go ahead and build your career into data science specifically. Now, going ahead with this, I'll also would like to give some real-time applications, where your machine learning is specifically used on a real time. Maybe you could be aware of this, or maybe you're not aware of this. So this gives you a brief idea, like where exactly machine learning works basically. So you would have seen your Google Maps, where Google Maps is one of uses a machine learning based application, where it will try to, let's say for example, if you search the distance, okay, if at all, from if you're traveling from point A to point B, and if you search the same thing in Google Map, if you can observe, it will show whether there is any traffic there, or it will also highlight, if at all, if the road is not proper, or if something is happening there, it will try to suggest some different route with which you can travel to your destination B from destination A automatically. Now how it does, basically huge amount of data about the traffic, about the location, everything is being fed into the model. So it will learn the data in such a real time, and on a real time basis, it will actually give you all that information in much precise manner. It will try to predict what is happening in that particular route, or it may predict what is the time which may take for you to reach from point A to point B. All that prediction will be made so precise, so that the model is learning in such accurate manner. Similarly, like chatbot, whenever you open any website specifically, you will find a chatbot basically, where if you type any question, automatically it will give you an answer within seconds. Now how it is trained, you ask any question, it will give you an answer. How it is done basically, or the best example for this is your Siri, which is there in your iPhone. Okay, so which like basically like you ask anything and it will give you an answer. Or even in your Alexa, which is there in your Amazon, or like Google Assistant for that matter, which if at all, if you're using your smartphones, which is powered by Android. Now whatever you ask them, they will give you a reply. Now how do you think it is done? So basically, what's any sort of a question which could be possibly asked by a customer, all that data of those questions is being fed into the model there, okay, into the chatbot, which is represented as a model. So since it has understood all sort of a expected question, and all expected answers which it should give also would have been already pre-programmed into it, whenever you ask any sort of a question, so it will automatically give you related answers for it. So that is one of the application of your machine learning. The example is Google Assistant, which I just gave you just for the chatbot as well. And also this is something relating to your Uber or Ola, okay, where they use something known as surge pricing. Now, what is this surge pricing? Just imagine that if you're planning to travel from point A to point B, and let's say the distance between point A to point B will be around 10 kilometers. So let's say early morning around 7 a.m. if you try to book a Ola cab for the same distance. So let's assume that it will be showing you around 300 rupees as a fare. Whereas if at all for the same distance, if at all if you start booking, or if at all if you book at, let's say, around 9:30 p.m. or sorry 9:30 a.m. or 10:30 a.m., so the price will automatically go up. Now, why it will go up? It will specifically the price is calculated based on the amount of traffic which will be there, the amount of like if at all if there is any rain which is happening, if it is raining, it will give you a high price. If there is a huge traffic jam, it will give you a high price. Or if at all if there is a huge crowded area, okay, where there is some event or occasion which is happening, because of which there is a lot of congestion in the road, basically, because of which if it is taking time for you to travel from destination A to destination B, in that case, again, it will try to increase the price. Basically, this is called as surge pricing. Depending on a particular situation, the price varies. Now, what price should be set will be automatically decided by your machine learning model. Okay, so based on all the attributes which it takes, basically. Similarly, another best example is your Netflix or Amazon Prime, video recommendation or a movie recommendation. Whenever you open your, Netflix, based on your previous search or based on your previously watched movies, okay, it will try to recommend you some movies which are related or somewhat connected towards your previously observed movies or previously observed like videos, even in terms of your YouTube. Now, this recommendation engine basically works with an application of machine learning, basically. Okay, so all this area where you can actually work in this. And one more example is with your this will be very familiar for you, where when you go for visiting a website like Amazon or a Flipkart, you can see that it will give you a product recommendation. Now, what is this product recommendation? If at all if you're purchasing a particular product, it will try to recommend some product which is connected to that particular product. There will be some connection or there will be some relation between the product which you're buying and the product which is recommended. So how it will try to do this basically is it will observe lots of customer who would have purchased this particular product. Okay, if at all if so many customers are purchasing a particular shoe, okay, it will also observe what other products these people would have bought. So once it observes what other products these people have bought, it will try to link it with your demographic details specifically. Now, what could be your age, what could be your buying pattern, what sort of products you have purchased in the past. By taking all of these information into consideration, it will try to suggest you those products. Okay, so that you, if at all if you look at it, maybe you may buy it or you may not buy it, but that's a secondary. But this is how basically the recommendation system will try to recommend you in order to push your sales, in order to obtain more revenue from the customer. So for all of these aspects, in a reality or in a real time, basically your ML application works tremendously, or basically it works in a very great manner. So this is where your ML plays a very, very, very important role, basically, in like helping the business or scaling the business to the next level. So this is how like the things which are there. Specifically, if you people are planning to make your career into data science, I would strongly recommend that you should go through all of these machine learning techniques, learn it practically, implement it, and with that you will be able to get good amount of like data, specifically like a good amount of knowledge upon all these technologies and techniques under machine learning. So this was specifically designed to give you a general overview of machine learning, what is machine learning, what happens there, and things like that. And so any questions, anybody, if at all if you have, please ask me. So like I have given you a general brief about what could be machine learning, machine learning, what are the things which is there. So if at all, if you have any questions, you can ask me. Okay, I have a question called is statistics required for learning machine learning? Yes, obviously, statistics all plays as a foundation basically for machine learning. So you should be knowing statistics, and you should have a very strong command on statistics in order to learn machine learning, because that gives you a path or a direction to learn basically. Okay, okay, I have a question called is the math intuition is very important. Okay, is the math intuition very important while learning machine learning? Yes. See, math intuition plays a very vital role. But on the other hand, since we are not going to do every single math calculation manually, so it will be taken care by the tool which we use, like be it in terms of Python or in terms of R or like Spider, any other advanced tool which is there, we'll automatically take use of those tools. So like there is no need specifically to know each and every input in terms of a math intuition, but if you know it, it is good. Okay, I don't say that you should not know it, but if you know it, it is pretty good, because you will actually understand how exactly each and every single machine learning algorithm is working. So you will easily understand each and every math intuition there specifically. Okay, so any other questions, anybody? John, any questions do you have? Karthik, any questions? Any more questions? Okay, no questions. Okay. Kausalya, Soundarya, you people have any questions regarding the same? Like, have you guys got at least a general brief, like overview of what is machine learning, why it is used, what all different aspects which comes in machine learning? Have you understood this, everybody? Okay, so if this thing is clear, then like today's specific more motto of my webinar is to give you was to give you specifically the general overview of machine learning. If at all, if you are planning to make a career into machine learning, then what all things you should focus on, what all things you should learn specifically. So I hope probably you would have got good amount of knowledge upon machine learning. So I believe whatever we discussed, like whatever information I gave, probably it would have given you a brief idea at least about machine learning, which may help you to decide to go ahead and make your career into this particular path here. Okay, so any other questions if you have, you can ask me. Okay, no questions. Fine. So if there are no questions, then I would stop my session here. Then I would stop my webinar here. So once again, thank you so much, all of you, for attending the webinar. So I believe there is some takeaway which you would have got from this webinar, with which you can like obtain certain amount of information about this particular webinar of machine learning, that is supervised and unsupervised machine learning. So thank you so much, all of you. See you all. Have a good day. Thank you.